So the case study I'm walking through today, just some background about how aircraft work. So any plane you've ever been on, kind of when it gets to the end of its service life, they need to decide what to do with it. They want to recycle as many parts, especially planes that are no longer being manufactured. So I'm going to walk through what that process is of when it gets close to the end of service life, someone goes ahead and decides they want to buy it. But it still operates as an aircraft. So aircrafts that you're flying on, they're already starting to part it out and sell these parts. So for the Airbus 318 that I'm going to talk about today, they're already saying let's figure out who's going to buy this landing gear, what condition it's in, what is it worth, what parts need to be refurbished. And then the other problem is as that aircraft is still in service, they need to continue to track the condition of that part because that aircraft is still undergoing maintenance. All right, so we'll restart this talk. So first, a little bit about us. We're mostly iPhone app developers. Our apps have been downloaded a ton of times. We've had 7 #1 iPhone apps in the store. Nothing recently. You might know us from things like Face Swap, before Snapchat took that. But most notably, we're always iterating, zillions of failed ideas. The one way to kind of stay ahead in this space, as with XR and VR, is you just have to constantly be ideating. So we're computer vision specialists. Now that we're in a world of spatial computing. So this is a project we did for Volkswagen in the top where they tracked cars. We do a lot of stuff with foot and body metrics, storage, do data gapping. That's what that is with the Vienna Castle down there in the corner. And we've been in this space a really, really long time. We've made our first AR app in, I think it was 2010 with Microsoft Connect. And I've been doing XR for even longer. These the virtual dressing room and a project I did for a museum in Holland where we visually projected assets onto you through glass. So now back to kind of the case study. What is rapid inspection and documentation? And that's where cost and time are really what's driving it. So where is it, what condition it is, capturing it very quickly. And this is using usually your mobile phone to do that capture and do that 3D reconstruction. Very common in material assets or piles of gravel or documenting an accident. And it's used throughout a ton of industries, everything from shipping and measurement to construction and geospatial, and manufacturing, real estate. I'm sure everyone's looked online, you've seen a virtual tour. Well, a lot of our projects involve move in, move out in apartments, so just documenting the condition of a space before it gets turned over, so what you get your deposit back or not. So in a typical rapid inspection workflow process, we have our capture, our storage, and collaboration. So in the capture, you're scanning. Again, most commonly, you're doing this with a mobile phone, a low-cost device. You can also do this with really high-precision devices, but that usually takes a lot longer, costs more. You usually need a professional to do it. During the capture process, you also want to document it. That means annotations, writing notes, doing character recognition, capturing text, QR codes, taking 360 photos, things that create virtual tours. Then you're uploading that to the cloud. You're cataloging, you're storing it. Sometimes you're post-processing it. Some of you have probably seen Gaussian splots. It's this new rendering for 3D that creates a very lifelike environment. And eventually we get into collaboration where you've got web tools and you've got spatial review. And that involves things like the Quest and the Apple Vision Pro, which are great headsets for this. So again, going back to capturing, what we specialize is in writing these capture pipelines to render on your phone. So that's really capturing 2D images with pose information. Where is that camera in 3D space? The depth data, your iPhone has a LiDAR sensor on it or has an infrared sensor on the other side. We can also just use pure images for photogrammetry. We also start to collect a lot of other information, like the GPS, the date, the user, and then also annotating images, just getting barcodes. So you have this large data set of ground truth that we can reprocess and use in any analysis of the data. So back to what I was introducing earlier, we're going to talk about aircraft. So the Airbus 318, they made about 80 of them from 2001 to 2013. They're primarily for Air France, but there's about 60 still in service. Air France has sold most of them out. None of these parts are really made anymore. There wasn't a lot of cross parts between this Airbus model. So they need to be constantly like, if the one's reaching the end of its life, what are they going to do with it? How are they going to resell these parts? So you need to inspect and document the parts of the aircraft as it's still in service. So today I'm just going to talk about the landing gear, the front landing gear of the A-13. So it seems like a simple part, but it's incredibly expensive to remanufacture these parts. So they need to be documenting the condition of the parts of aircraft that are still in service, that are kind of getting towards the end, and keeping tabs on their condition and for people that might need them, and they keep a marketplace for this. So we don't really need a really great 3D reconstruction because we know the part in the serial. We have CAD drawings. So a lot of the things you've seen out here is about matching CAD drawings to scans. This is more about condition documentation. We know the part, is it damaged, does it need certain maintenance, is it starting to rust? So what we first do is we capture the parts. So we've equipped this team with iPads and iPhones. So they go out in the field and they scan parts of the aircraft and they make notes. You see the blue dots are notes they made on particularly like the condition of the tire or some rust they spotted, a hydraulic leak. And then they can also make field notes. So they take 2D images. What I was getting to earlier, the 2D image is something they know best. Like if you look at 3D scans, a lot of times they're point clouds or they're meshes, and they have some fidelity problems. So what we do in this workflow is we go back to what we like to call the ground truth, which is a 2D image. It's something engineers and everybody's been working with for a long, long time. So it allows them to make the mock-ups, extract any text they might see, create field notes. And what we're talking about is the value is in the 2D images and where they exist in 3D space, not necessarily like the 3D reconstruction, because they already know what that part is like. They just want to know if I want to get a picture of the left tire and that front landing gear, I can go immediately to a model and bring that up and look at the condition of it. They can also mock up notes in 3D. So, they can paint on the surface, or as I showed you earlier, they can draw on a 2D photo. And then we've developed a web viewer where it allows them to bring up the poses of all the images that were taken during the 3D scan, so they can view that image in more detail and make notes on it. Here they're looking at a particular part on that landing gear assembly. And what we've done here is kind of exciting is we've implemented, some LLMs into these large language models. A lot of our work used to be, we'd do scanning, we'd write these incredibly complicated, CV problems that we had to train on large data sets. These LLMs are really good at just looking at something, and you can feed it some information about like how big that photo is based on angle, and it can really start to pull out, what it's seeing, any text. And what's really crazy is a huge problem in computer vision is partial text. So if you have 100 photos and it's got a little bit of a serial number on it, that used to be like you had to kind of mat them all together and make like a panorama that you're probably familiar with, and then try to extract that from a single image. Well, LLMs are very good at making like individual documents with partial text in them and then summarizing them. They're not perfect, but we see where this text is going. So projects that used to have huge costs associated with training specialized computer vision pipelines, we can now throw LLMs at them to pull out key information, do assessments. We've done this in the medical field and other things where we can start to look at skin conditions, and make an assessment of someone's like moles on their hand or their head. But one of the focuses at the conference here today is the Apple Vision. So in that pipeline, at the very end of it is, having remote engineers be able to like interact with this data spatially. It's something they're used to. They used to be able to go on site, but the Apple Vision with its fidelity is just amazing to get into a scan and look at it, very closely, both in 3D and then also bring up, these 4K images along with it, so they can really understand what's going on and make engineering recommendations for service and repair. So we've been developing a lot on the Apple Vision as soon as it came out. I was kind of not plussed about it when they first announced it. I didn't understand why Apple wanted to get in the game, especially with a really expensive device. But I'll be honest, I've just been blown away with the fidelity of it. We even made a fun little app for it called AirDraw, if you want to play with it. But it's a very impressive piece of device, and I can see it really getting adopted more and more in enterprises. You've probably seen a couple hundred of these things floating around the show, if not more. it's been exciting. We did a project for one of these high-precision LiDAR scanners so they can view point clouds. But OS 2 has introduced all these new features. One is really accessing the camera. So now, as a developer, you can see what the Apple Pro and start to really analyze it at the same time. For you techies out there, you now have access to the Meta language, which you couldn't do before, and you have access to play with the mesh. Object tracking, you'll see some demos on Twitter about that. We just, as of today, got like the entitlement that we can play with it. It's a developer access. There's a lot of new features. So I think with Apple Vision OS 2, it's going to be a lot more mature ecosystem. We were planning to open source Apple AirDraw, but Apple kind of beat us to it, which is nice. We don't have to clean up our code. They've open sourced a drawing app, so any of you that are developers in the room and you've installed OS 2, this is a really fun sample app to work with and play with low-level meshes. So, as I said, we keep our team very small. My brother and I have been through 1 million startups. We kind of have more what I like to call lifestyle business, where we don't have to manage people, and we can focus on problems that are interesting to us, which happen to be computer vision, especially in the 3D and spatial computing space. It's been really interesting to see, XR and VR mature. So, it's just a fun space to be in, and it's exciting, and every day you kind of see some new advancement. So it's like, I just can't say how excited I am to come to conferences like this and see all the new things everybody's doing. So I wanted to open up for questions anybody has. I usually like to leave, I've left a little more than 10 minutes, 12 minutes. So if anybody has any questions about the space or computer vision or Apple Vision Pro or developing on it, please ask away. Oh, we have an engaged audience.
All right. We'll open up the floor for questions, and I'll run the mic cue so that we capture the audio on the recording here.
No questions? I can just keep rambling.
Got one over here.
Hi, I'm Michael with Northrop Grumman.
Yes.
So really interesting, the system to note condition of landing gears. Do you have interfacing a pipeline into for example, a quality system, or can we tap into the data programmatically?
Yeah, this is an API that you can access. So it just it's a cloud service that has APIs to various endpoints. So you can bring it into other systems. If you have, it just depends what you need it to interface with. So, we store the mesh, all the images, any information that's extracted with the mesh, the notations, 3D and 2D notation, and also just any, text notes as well.
Can I ask a second question? Did you say you use LLMs to learn from the conditions? So can you elaborate on that?
So here, this is just running Gemini's 1.5001, but you can have a trained LLM. But typically what we do is run one OCR pipeline through it, and then we'd run another one that was trained on cracks and rust or some other information. But what has been so interesting here, in my opinion, has been the document summary. So every single photo we create, what does the LLM see? As much information. We ask the question in a few different ways. We kind of have some embeddings to pre-train the setup, and then doing this summary. So you really have what would take a field engineer a long time to do. Now, I'm not recommending you certify flight worthiness with something like this, but you can see where it's going. Is all of a sudden it takes all these partial text, documents, and it summarize it, and then you can say be more concise, highlight any critical errors. So you end up with 1 or 2 sentences about a part, and it's pretty good, and it's obviously going to get better. And you can really train it more to look for this. If you see this in a photo, look for this type of thing. If you see, what appears to be fluid, that's probably hydraulic. And that's been an ongoing experiment. This is not something live, but it's been really just. That whole space is just. It's blown me away. We've been, working with LMs for a while, and it kind of is weird. It just passed us by. I just didn't think it would move this fast. I don't know. Maybe that's for a lot of people.
other questions? I'll go ahead and ask one question as well. I was really interested in how transferable do you think this system that you've created here would be if we wanted to, for instance, apply it to analyzing the status of industrial robots on a shop floor or an industrial kitchen or something like that?
Well, that's the idea is, we are, I was trying to, I showed one slide on the various industry. We've been doing kind of the rapid inspection and documentation for like accident scenes and, a little about what we do is we license 3D reconstruction pipelines. So it is very transferable. I think as the technology becomes more mature, you're just going to see this in so many things. Like we did something for a German property management company I mentioned earlier where, move in and move out. Just someone could walk in and quickly scan an apartment and make notes of just like, is there damage here? Was there water? Is the carpet in good condition? But, this can almost be done automatically. You're just asking someone to go in. Probably a drone will do it in the future and fly around, and then you'll run all those images through an LLM and it'll be like, this property move-out condition was rated a B, with these known faults. So I see this moving very, very rapidly. We're already doing some medical projects and things like that.
One question curious about if you have some information of how users actually use it. For example, people in the field, like if they have to operate, like usually the input is probably pretty tricky. So I'm just kind of curious.
Well, usually what we typically do is we, train someone on a capture. These apps are getting fairly common. You probably used like the more consumer-oriented ones like Polycam or, Niantic has Scaniverse, which is, and there's a couple others out there, is, you get real-time feedback as you scan, as the mesh is created. So you're seeing that you're doing a good job. It usually takes one or two. We have a free version of the capture side in the app. It's called 3D Scanner app if you want to play with it and see how intuitive it is. But we have high success with people doing good captures. And usually, with a couple training, depend on the object they're capturing, learning not to get things that are highly reflective or giving themselves proper spacing and time and not moving too rapidly during the capture, we get excellent results.
All right.
In terms of capturing the 2D photos and then generating these 3D images, are there ever any issues with like inconsistencies with making sure that it's actually capturing issues with the actual system, like a crack? Does it miss it when it generates the 3D version?
So what we do for that particular problem, making sure you have a photo that's of a part that you have interest in, is as you're scanning, most all these applications like photogrammetry, you're taking, photos at the same time, and you may not have the right particular angle. I guess this would probably illustrate this better. So, you're seeing these camera poses. What we've built in that UI is that after you've taken the scan, you can click on a part and you can see that photo. But if you don't have that, you can add a note like this blue dot and then take a close-up photo of that. So, that process is get the scan, capture the 3D, review, any parts yourself, and make sure you have close-up photos of anything that is of interest or concern during that documentation process. And that's also asking people to take field notes, draw things. Here we're showing someone taking up a 2D photo and making a circle around something as especially concerning to them.
Hi, Erica from Lockheed Martin. I guess it's not really a question, more of a comment, but I don't know if you've ever heard of, there's a company called Air Innovations, and they're doing some really great stuff where essentially they're able to take a borescope video of an engine and review it with AI to be able to pick out the defects and identify that there are defects, and it's YASA approved at this point. I think what we're kind of looking from industry is to have that similar concept, but merge it with the AR, and then also not only that, but expand it beyond the borescope of just HPC blades, for example. So for example, if I was able to look at the landing gear and it point out, hey, you have a defect here, I think that's what we're all kind of looking for from AR.
So, that's what we're trying to do right now with LLMs. Obviously, so here you see someone manually doing it. They're doing a scan and they're putting notations on things, those blue dots. in that upper left-hand corner. But the idea, what I'm trying to illustrate here with kind of the LLM annotations is it can go through, and as it sees a 2D image and it does a computer vision problem, it can project that back into what 2D image that was in that 3D space and say, all right, here's a point we need to review, and automatically identify, here's things that are of concern. So, speeding up this whole process. Again, that's this, we call them rapid inspection and documentation. Like, we have another client that, is working with things where they do destructive testing. So they have to quickly document a scene before they do cleanup, so that they get to document it, run it through these processes to, bring problems to light very, very quickly. All right, we have a few more minutes if anybody has any other questions or anything they want to talk about. Anybody here developing on the Apple Vision at all, or is this mostly industrial people? No more questions? End of day, everybody's tired? Looking forward to the Augie Awards.
I think we'll wrap it up here, but let's give one more question.
Yeah, I'll just shout it out. Wish list from camera scan manufacturer technology.
So the question was, wish list from camera scan manufacturer.
I mean, you're talking about like what Apple's putting in depth sensors and things? Yeah. I mean, that's a huge problem. I mean, for instance, like the true depth sensor that's on the front, we use that a lot for medical. They've severely downgraded that sensor, from the iPhone 12 to the iPhone 15. And, we have no idea if they're going to get rid of the LiDAR sensor. They may be like, actually, the cost of manufacturing this outweighs what we can do now with, AI to take a good photo. That's why that's in there. There's this very small market segment that's using it for depth information. But, yeah, that's a huge... So the AVP, as we said, they just opened up these APIs to let you access that camera, but they're very, very privacy concerned. So right now we can get access to that data, but we can't get access to a lot of the raw data. So we can kind of see the camera, but again, I was just mentioning we just got the approved today to actually look at that raw data ourselves. I haven't even played with it, but I'm hoping that's the case, because it's such an interesting, ecosystem, and we've invested so much tech into building out, for the iOS ecosystem. From a tech side, it was really frustrating when they released the first version of the Apple Vision Pro. It's really hard to develop in it. They didn't really give you any access to their low-level, rendering pipeline, this Meta language.
All right, well, let's thank our speaker, Jason, one more time.